Okay, we're here behind the Chino Valley greenhouse. We're talking a little bit about cooling systems. And so what you see behind me, this device, this is a pad vent. The pad vent opens to allow air to rush into the greenhouse when it's warm outside. So you notice all of these pad vents are open now to some degree, allowing air to come in. If I look inside here, there's these cooling cell pads. Right now water is not dripping on them because we still are in that season where it gets close to freezing at night. But what will happen as temperatures continue to rise, water would be dripping down through these pads, and then air would be rushing inwards. This is the sump unit where water is held that leaks onto those pads. Above me here are the gable vents. These are vents at the end, and so in the winter time when it is pretty cool outside, just the gable vent can open, allowing for air to rush in when one of the fans is running. So this is the end. All the bays have pad vents open. All the gable vents are open. These gable vents will close automatically when water starts to drip on these pads, so that air does not force through there. It will force air to come through the evaporational cooling of the pad. So one starts to turn, then the other one starts to turn. When they're not turning and it's cool enough in here, the vent closes. It's got this flap to it, so it closes up tight, so in the winter time you're not losing warm air that's going out. Once air is blowing out of these, what's happening is it's forcing air out of the greenhouse. The fans are pointing outwards, and so that pulls outside air in, and so the pad vents have to be open. The next stage, if it's still too warm in here and it goes to the next cooling stage, then the gable roof vent at the end that is open, it closes and water starts to drip on the pads in the back. The pads dripping water through them, like I mentioned, causes evaporational cooling, and so it's pulling in air from outside through these cells, and these cells, as the water evaporates, it brings in cooler air than outside. These are a little tough in the summer when it's really moist and really warm outside. The evaporational cooling doesn't work as well. But we can keep this greenhouse between 65 and 85 degrees, no problem, with a functioning cooling system. The two heat stages we have would be heater number 1 and heater number 2 in the front of the greenhouse. So these heaters have to be sized large enough to heat this cubic footage. And so what happens in the winter time, if we're trying to keep this at 65 degrees, as soon as the sun goes down, the temperatures drop and these heaters kick on. So it's pretty intensive with gas usage in the winter time, because the heaters almost run all night long. In the spring and summer, maybe just one heater runs, and that would be one heating stage, and one heater might be enough to keep it warm enough. Okay, it's warm enough in the tomato bay, and the fan is running, and so I feel air being sucked outwards. This also helps protect from insects coming in, because anytime the flaps are open, being pulled open by the fan running, and even the fan itself has different stages of speed that it's running. So now it's just casually running because it might be 65 or 70 degrees outside, but now it's really starting to get going now. These fans that are spinning need to be sized right to, it just shut off. Did you see that? I'm not even touching it, automatically shut off. So it just reached the cool temperature in here. What I was gonna say is these fans need to be sized right for the cubic footage of this greenhouse. It's an air mover. How much air can it move out of this greenhouse to efficiently cool it down? And so that's why we have the stages. Bring in that evaporatively cooled air. It's really important so we can grow this tremendous crop that we have. As I look at the front of the greenhouse, you can see different fans running on different stages. So not running, just barely running, and this one's really cranking, but it's in a different bay. So the line for the separation is here. So this one is controlling 2 different bays with different set points. So you can really get some amazing specific climate control. Okay, so we talked about heating and cooling. There's some other things here, roof, shade. We're not using the shade, but someday we might want to. The shade could automatically open and close. This is a humidification fan, and so right now it's on auto and it's not running. Just the air in here is causing that to turn a little bit, but I have the ability to set the control to dehumidify more or less as needed. So if I came in here and I decided I wanted this system to run automatically, I can flip this switch to on. You hear it come on, and now that fan is running. And so if I switch this back off again, now that fan has stopped. I want to put it back in the auto position where it'll run as needed. So this climate control system has the ability to really help maintain the climate that we keep in our greenhouse. Another way to reduce temperature is by shading. So here in the aquaculture area, they have that shade cloth that I was telling you about, and this can be automated from the system. It bunches up and it can close or open. It's oftentimes called an energy curtain because the heaters will keep the heat and the warmth down close where the plants and fish require it. In our area, this was already breaking down, and the actual twin wall polycarbonate was starting to get older and discolored, and so we weren't letting enough light in for plant growth, and so we took down the shade cloth in our area. Even though the runners are still there, you can see a few tattered pieces of it, but we were noticing that the lettuce was just way too wilted. The sun intensity was too high because we couldn't control the warmth. And so we put up our own shade cloth system to reduce the light on these crops that don't need as much light. So that's a model for cooling, but it's not part, in this case it's just draped over. It's not part of our system that opens and closes as needed. One other method we have for cooling this greenhouse is the use of mist. And so we are watering in here. Every time we water in here, just the introduction of the water and the moisture cools down. Even though this isn't controlled by the iGrow, it's controlled by another timer that controls just the irrigation. So I see here the drip just started running on these hanging baskets. Water is dripping out through the pots. This is quite a bit of moisture in here, and the temperature drops. But also, the humidification fans just started running. Winter and potentially in the spring, when the heaters are running, this is where the exhaust leaves the building.